Students, good afternoon. Mr. Fugit here. Today in this video, we're going to be looking at the concept of torque and rotation and how forces applied at a certain distance can cause objects to rotate or spin. In this video, we're specifically going to be looking at a force applied by a wrench causing a bolt that is going to tighten over a fixed point. So this problem is geared towards number 5 on homework assignment 12, covering over torque. Problem statement reads like this. If the torque required to loosen a nut that is holding a flat tire in place on a car has a magnitude of 44 Newton meters, what minimum force must be exerted by the mechanic at the end of a 20 centimeter long wrench to loosen the nut? So here, when dealing with torque, it's usually very helpful, as it is with a lot of things in physics, to draw a picture of what's going on. So imagine if we zoom in to the tire, we're going to focus on my best bolt there. We're going to focus in on a bolt. So imagine we have a bolt that we want to rotate. Now how this would work is that we would attach the wrench, let's say kind of the teeth of the wrench around the bolt, and then a wrench has a handle attached to it that allows us to create that torque a little bit easier, provides some leverage. Now we're told a few things about this scenario. We're told that the wrench has a length of 20 centimeters. Now we're given that value in centimeters. I'm just going to immediately convert that to meters. That way, when I go to plug things in, we have our values in the units that we need. So 0.2 meters. Just move our decimal 2 places to the left. Now we're told the torque required to loosen a nut that is holding a flat tire in place on a car has a magnitude of 44 Newton meters. So if we want to loosen this nut, let's say we need to apply a torque. Loosen usually is to the left, so we want to apply a torque this way. And we're told the torque needed to loosen the nut is 44 Newton meters. Now, in order to create that torque, we're told that the mechanic applies a force, we're told, at the end of the wrench. So I'm going to come over here to the end of the wrench, and if I want to get my nut moving what would be counterclockwise, I'm going to need to push up on our wrench. Apply some force. And the question is asking, well, how much force do we need to apply? Now, it does say what minimum force must be exerted by the mechanic at the end of the wrench to get this nut to loosen. So, just because it says minimum force doesn't mean we're going to change our approach, because we're told the torque needed to get our nut just to loosen at any rate is 44 Newton meters. So what that means is this is our minimum torque, meaning this would be our minimum force. If we want to create more torque, that's fine, but we need a certain amount in order to get the nut to loosen. So I'm going to look at my equation for torque that looks like this. Torque is equal to force applied at a distance times sine of the angle between those two vectors. Now, we know a few things about what's going on here. We know the torque we need to create is 44 Newton meters. We don't know how much force this is going to require, but we do know our wrench is 20 centimeters or 0.2 meters long. We're applying a force at the end of that wrench. Now, we do know a little bit about the angle, even though we're not told that information directly. Our distance comes out straight horizontal. Our force goes up vertically, making a 90-degree angle. Now, as we talked about over the last couple of days in class, sine of 90 degrees is going to give us a value of 1. So mathematically, it's not going to change really how we approach solving the problem. So multiply by 1, or you can leave it off if you feel more comfortable doing that. So in order to find our force, as you can tell, we have 2 of our 3 variables, and we can solve for our unknown. So on the right-hand side, I will divide by 0.2 meters. Because we have an equal sign in the middle, what we do to one side, we have to also do to the other. So 0.2 meters, we'll divide that over to the other side of our equation, and we'll be left with a force, well, that is 44 over 0.2. So let's plug that in. Well, that gives me a value of 220, and the force will be measured in newtons. Okay, so for the most part, looks like we solved this right. Let's check our key and see right at 220, right at 220. Okay? So the idea is that we're really just looking for the amount of force needed to create that torque of 44 Newton meters. Okay? Don't allow the word minimum to throw you off. Hey, the minimum just means we want to create that exact torque of 44 Newton meters, excuse me. Okay? Now, if we wanted to create a greater torque, we apply more force at that same distance. Or we might look at changing our distance, that would change some of our other parameters. Okay? But the idea here is we're using our torque equation to figure out a force needed at a certain distance. And hopefully this will help get you started on this problem. Hey, best of luck.